So let's talk about normalizable functions then. A function f is said to be normalizable or quadratically integrable if the integral here that I've written here, integral of f star f d tau, is a finite number. Okay, what did we say d tau meant? Integration over d tau simply means integration over all possible locations. So if your particle can only be in one dimension, it can be from x equals negative infinity to positive infinity. But if you're going to confine your particle to, let's say, negative 1 to positive 1, then the integral over d tau would be from negative 1 to positive 1. Okay? So integrating over d tau means over all possible space where the function is applicable. So it could be, for example, from negative infinity to infinity. Now, to normalize your function, okay, you simply multiply it by a constant n so that the integral here is equal to 1. So if this is equal to some finite number, then we say f is normalizable. If this happens to be equal to 1, then we say f is normalized. Okay, so let me repeat that. If integral of f star f d tau is equal to a finite number, what do you call f? F is normalizable or quadratically integrable. If that finite number happens to be 1, integral of f star f d tau is 1, then we say f is, not only is it normalizable, it is already normalized. So we say f is normalized. Okay? So, let's look at this example. Suppose this integral is equal to 5. Okay, what do you call f? Is it normalized? No. Is it normalizable? Yes. So, how do we normalize function f? Well, let's define g to be some constant times f. Okay? So, what would be the integral? We're going to look for n so that integral of g star g d tau is equal to 1. Okay? So, how are we going to do that? We're just going to substitute nf for g. So, that's your g, right? That's nf star times nf, that's your g, d tau must be equal to 1. How do I solve for n? What is nf star? Well, how do you take complex conjugate? Every time you see an I, replace by negative I. And if you just have a variable representing your number, you don't know if it's complex or real. N can be complex or real. F can be complex or real. So you just star it. Right? So this is going to be N star, F star, and F d tau is equal to 1. And I can factor out a constant for my integral, right? So that comes out N star N integral of F star F d tau is equal to 1. What's the integral of f star f d tau? Let's solve for n star n. This is equal to 1 over the integral of f star f d tau. So we said that this was equal to 5. So what if that was 5? Then we say the normalization constant, absolute value of that is equal to 1 over. That doesn't mean that n is 1 over square root of 5. It simply means absolute value of n is 1 over square root of 5. If you recall, okay, so n can be 1 over square root of 5. It can be negative 1 over square root of 5 because its absolute value is still 1 over square root of 5. In fact, n can be any complex number that's represented by this circle on the complex plane. Any point on this complex plane that is separated from the origin by a distance of 1 over square root of 5 will have an absolute value of 1 over square root of 5. So in general, n would say 1 over square root of 5 times e to the I 5, where phi will be an angle from 0 to 2.